Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today, we will be doing second topic of Module 4, which is Humidity and Precipitation. And the topic of the lecture is Fog, their classification and distribution. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In various previous lectures that we have covered under Module 4, we have discussed several concepts which are related to humidity, atmospheric stability and instability. In this particular video lecture, we will be discussing fogs. What are fogs? What is the classification of fogs? And in detail, we will be discussing the distribution of fogs. So let's begin. The main objective of this particular video is to understand what fogs are. The general characteristics of the fog will be discussed. What are the conditions which leads to the formation of fog and how they are formed? Then we will be discussing what are the different types of fogs. Then we will be proceeding to the world distribution of fogs, and finally the fogs and their impact on environment and human beings. What are fogs? You might have definitely seen white, blurry, smoky coverage, thin cloud-like appearance, especially during the winter seasons. So what fogs really are? They are the manifestation of special atmospheric conditions and can be witnessed all over the world. The word fog refers to the special type of cloud or smoke particles, ice particles, or mixture of both which hinders visibility. Fogs can be thin or thick depending upon the level of invisibility and people facing difficulty seeing through it. Fog is generally seen as white, blur, smoky cloud-like formation near to the ground surface made of tiny water droplets or ice crystals suspended in air. So there are special types of clouds which are generally found near to the ground surface. They are suspended in air and they remain very near to the ground surface. As you can see in this particular diagrams also, fogs can be very thick and they can be thin also. Fogs are also generally associated with numerous weather conditions throughout the world, but mainly they are the manifestation of processes like radiation, conduction, and mixing of warm and cold air masses in the frontal zones. So fogs can be seen all around the world, although their intensity, thickness, thinness may vary according to the conditions which are present in different areas of the world. Defining fog. Fog is a special type of thin cloud consisting of microscopically small water droplets which are kept in suspension in air near the ground surface and produces horizontal visibility. So these small water droplets, which are very microscopic in nature, which are present accumulated in fog, they are kept in suspension, which creates white blurry like appearances, smoky appearances, reducing the horizontal visibility, so much so sometimes that it is even very difficult to see past through them. According to Byers, fog is defined as almost microscopically small water droplets suspended in air in the atmosphere, reducing the horizontal visibility to less than a kilometer also. So based on how much a person can see, how much is the level of visibility, the fog can be categorized as light fog, which are also called as mist, and here the visibility is beyond 1 kilometer. That is, it is a very light foggy appearance and person can see beyond 1,000 meters also. Then you have moderate fog wherein the visibility is reduced and a person can see from half kilometer to 1 kilometers of range only. Then you have dense fog where the visibility is further reduced to 550 to 300 meters. And then you have very dense fog where the visibility is hindered so much that it is very difficult to even see beyond 300 meters. So here in these pictures, you can actually see the visibility conditions in different types of fogs. This first picture is of light fog, where you can see that it is the visibility is somewhere around 1 kilometer. Then you have the moderate fog, where a person can see somewhere around half kilometer to 1 kilometer of range. Then you have dense fog conditions where it is difficult to even see beyond half kilometers of range. So the visibility is somewhere around 300 to 500 meters. And in very dense foggy condition, one cannot see beyond 300 meters. So you can see a train is approaching, but it is hardly visible in this particular photograph. So fogs can be of different types depending upon their thickness and visibility conditions. Fogs are formed in different regions of the world. There are different types of fog. However, there are certain basic conditions which are required for the formation of fog. Fogs are formed when it's very humid. The air has to be very humid, so much so that the relative humidity exceeds more than 97%. There has to be a lot of water vapor in the atmosphere so that it can condense and form fog. Secondly, there has to be the presence of any kind of particles. It can be dust, smoke, pollutant particles in the atmosphere around which the water vapor can condense and form fog. So these particles act as base for the water vapors to condense around them. And these particles, microscopic solid particles, are called as hygroscopic nuclei around which these water vapor condense and form fog. Third, very important condition is prevalence of very cold conditions, because very cold conditions help the water vapor to condense and form fog. If the conditions are warm, the water vapor is going to evaporate. It may yield precipitation. It may rise up in the atmosphere, condense, and lead to precipitation. But under very cold conditions, only the water vapor, when condenses, lead to the formation of fog. So, when all these conditions are present, the fogs are formed when the moist air with very high relative humidity, that is more than 97%, as we have discussed, becomes saturated, reaches its dew point, and even after reaching its dew point, it further cools beyond its dew point, so much so that the water vapor condenses around the hygroscopic nuclei, which can be again dust particles, smoke particle, pollutant particles, anything which form the base for the water vapors to condense and form fog. And these water droplets condense around these hygroscopic nuclei, forming very tiny droplets, which being very light remain suspended in air near the surface of earth, giving smoky blurry appearance, which is called as fog. So fog is definitely seen in different parts of the world. Different types of fogs are also there in different parts of the world. But these conditions are very, very basic for the formation of fog. And once this water vapor in the atmosphere condense to form very tiny droplets, they give this blurry white smoky like appearance, which is called as fog. Types of fog. There are different types of fog depending upon the mechanism of their origin, depending upon the phenomena which are involved in their origin. However, we will be going to discuss only few very, very important types of fog, which include radiational fog, advectional fog, upslope fog, steam fog, frontal fog, ice fog. Besides this, we also have freezing fog, barometric fog, mixing fog, and several other kinds of fog. But these types of fogs are most common and found in most of the regions of the world. So we will be discussing these only. Radiation fog. Radiation fog is one of the most common type of fog. Why? Because it is mostly associated with the heating and cooling of the Earth's surface and therefore witnessed across the world. These type of fogs are mostly experienced during the winter season over cool, moist surfaces. Why cool, moist surfaces? Because the presence of moisture is one of the basic condition for the formation of fog. Therefore, these types of fogs are best formed with the occasional rainfall and moist surface conditions. So even if they are formed over the continental land surfaces, the presence of moist surface conditions is very, very essential for the formation of fog, which is ensured by the occasional rainfall and showers in the seasons. Long winter cloudless nights facilitates excessive terrestrial radiation and the ground surface becomes excessively cool, which leads to the cooling of the air which is lying above the ground surface, so much so that the moist air cools, reaching its dew point, and further cools beyond its dew point, stabilizes, gradually leading to the formation of fog. Because these types of fogs are formed because of the heating and cooling of the ground surface, they are also often associated with temperature inversion conditions, wherein during the long winter nights or due to certain conditions, specific conditions, the ground surface becomes very, very cold and the air parcel lying over this ground surface also becomes very, very cold, leading to temperature inversion conditions in the area. And such areas often witness fog also. Such fog disappears in the morning with the sunrise. Why? Because due to the evaporation of the water droplets as the temperature rises. So radiation fogs are commonly associated with temperature inversion conditions, mostly observed during the winter season. Radiational fogs occur only on land surfaces and are mostly common over large cities also. Why? Because of the presence of dust particles, hygroscopic nuclei over the large cities, which allow the water droplets to condense and form fog, especially during the winter season. Radiation fog is very, very common in the valley regions. Why? Because the valley regions are most ideal location for the formation of radiational fog. Since these areas are generally sheltered from winds and can cool further under clear skies, and the colder air sinks from the mountains into the valley regions, leading to in temperature inversion conditions, followed by very, very dense fog. And this dense fog, which is very, very deep, is also called as fuel fog sometimes. It is often seen in the California Valley of USA, where very, very dense fog is formed in California. So what happened in valley regions, because the mountain tops becomes very cold during the night time, the cold air sinks to the valley floor And once this cold air sinks to the valley floor, the air which is present in the valley floor, which is comparatively warmer, is tossed up, and this cool, dense air takes the place of the warm air which is tossed up, leading to temperature inversion conditions, followed by very, very dense and deep fog. This fog is also dense mainly because there is very, very less movement of air in the valley floor regions. Hence, it takes time for this very dense fog to even clear during the daytime. So, such kind of fog is found in the California Valley. As you can see in the diagram, the whole valley is covered with fog, and even the Golden Gate Bridge, which is one of the longest bridges in the world, is not even visible in the California region. So radiational fog are most commonly found in the valley regions, where they become very, very dense and sometimes called as fuel fog also. Coming to the second type of fog, the second type of fog is advectional fog. As the name suggests, these types of fogs are generally found because of the horizontal movement of wind and may occur over land and water surfaces. So, as against radiational fogs, which are mostly formed in the continental areas or land surfaces, the advectional fogs can be found on any surfaces. It can be land, it can be water surface. They generally originate during the winters on land and during the summers over the sea surface. Warm, moist air moves over the very cold or snowy surfaces. It is cooled from below, stabilizes, and dew point is reached, and condensation of water vapor occurs, creating tiny droplets that remain suspended in air, leading to dense fog and humid conditions. So whenever a warm parcel of air is traveling over the cooler surface, the this warm parcel of air is cooled down from below, leading to temperature inversion conditions, and this particular area also witnesses dense fog formations, which are mostly formed because of the advectional condition, that is the horizontal movement of wind. Hence, they are called as advectional fogs. Next type of fog is upslope fog. Such types of fog are very, very common on the hill slopes in the temperate regions and may occur in different seasons of the year. So upslope fog is a kind of advectional fog only. Why? Because here also you can see the horizontal movement of wind. These types of fog originates when the continental warm, moist air is forced to rise upslope along the steep hill slope. So when warm, moist air is forced to rise up a hill slope, the rising air adiabatically expands, cool down, and gets saturated, leading to condensation of water vapor around hygroscopic nuclei, and as a result the dense fog is formed. So such type of fogs can be seen very commonly in the temperate regions and also during the winter season in the tropical areas also. So when the air is forced to rise up, it expands adiabatically and it cools down, and it may also leads to precipitation sometimes, but it definitely leads to the formation of fog in such areas. Next type of fog is steam fog. Steam fog is also a type of advectional fog when the cold air from the land moves over the oceanic surfaces, leading to evaporation of large quantities of moisture from water surface to saturate the overlying cold air. In the process, the overlying cold air is warmed from below, the water vapor rises upward and condenses on meeting the above cold air, leading to the formation of fog. The vapor particles above the water surface resemble steam type originating from water Hence, it gives a steamy appearances over the water. Arctic sea smoke is a very common steam fog that forms in the Arctic regions when very cold air flows over the warm waters, leading to the formation of fog. Another interesting category of fog is found in the frontal regions of the world, where the fronts are formed, which are generally the temperate regions of the world. Frontal fog is generally associated with warm fronts and forms when the precipitation falls into cold air and saturates it. So the fog in these particular areas generally occur when the two contrasting air masses, warm and cool air masses, converges along a zone which is commonly called as front. Because of contrasting properties of both the air masses, they are not readily able to mix up, creating a boundary in the mixing zone which is called as front. So because the warm air is pushed upward by the cold air. The overlying warm air is cooled from below due to the underlying cold air, leading to temperature inversion conditions, and fogs originate after the condensation. So once the cool air has totally taken up the territory near the ground surface, the warm air is pushed upwards, leading to precipitation and rainfall in these areas, which are followed by fog-like conditions also in these areas. The upliftment of cooling of warm moist air also causes rainfall, which saturates the underlying cold surface, and thus fog is produced in these particular areas. So fog in the frontal regions are generally associated with the rainfall. Fog is mostly post-rainfall phenomena in the frontal regions and can be seen in the temperate regions of the world. The last type of fog which we are going to discuss here is ice fog. These types of fog consist of fine ice crystals in the air instead of water droplets and formed in extremely cold Arctic conditions where the temperature is generally minus 29 degrees Celsius and even colder. The ice fog is of significant density is found near human habitations in these areas because there the burning of hydrocarbon fuels add large quantities of water vapor leading to the immense availability of hygroscopic nuclei, dust particles in the air around which the water droplets condense. Intense ice fog is formed in such areas. Steam vents, motor vehicle exhaust, and jet exhaust are the major source of water vapor that produces the ice fog in these areas. A strong low-level inversion contributes to the formation of ice fog formation by trapping and concentrating the moisture in a shallow layer. Horizontal visibility, because these fogs are very, very dense, the horizontal visibility is usually very restricted and it is often less than 50 meters. This is due to small diameter of the ice particle as compared to the water drop. Coming to the world distribution of fog. If the world distribution of fog is considered, it is apparent that they are more widespread over the oceans. Why? Because we have more ocean surfaces as compared to the land. The oceanic fogs are generally advectional in origin because relatively warm air coming from over the land surfaces produces fog over relatively colder ocean surfaces. So, advectional fogs are very common around the world, mostly found over the oceanic surfaces. Fogs are also found in the regions where colder ocean currents are seen, and the eastern portion of the oceans and the western portion of the continents often experiences fog. For example, you have the California current, Peru current, Benguela current, West Australian current. So in all these areas, because of the presence of the cool ocean currents along the continental margins, the fogs are formed. The formation of fog is also common in the frontal areas. Frontal fogs are produced in the high latitudinal areas due to the convergence of contrasting air masses which are not readily able to mix up and lead to the formation of fronts. So convergence of cold polar air mass with the warm westerlies in the regions leads to the formation of fronts, and these areas are very common for the formation of fog also. So all the regions which are located in the temperate latitudes, temperate regions of the world often witness the frontal fogs. The frontal fogs are more common in the northern hemisphere as compared to the southern hemisphere because of the presence of more land in the northern hemisphere. Hence, the contrasting cooling and warming properties of land and water leads to the formation of fronts which are more pronounced in the northern hemisphere. Besides this, fogs are also formed in regions where cold and warm ocean currents merge. For example, you have near Newfoundland. Here the cold ocean coming from north and the warm ocean current coming from south converges, leading to the formation of fogs. Similarly, we also have along the coast of Japan and in many areas where the warm and cold ocean current merges, the fog-like conditions are formed. Besides this, the radiation fogs are also formed in the lower latitudes, especially in the continental regions of the tropical areas, specifically in the winter season, mainly because of extreme cooling of the land area in the tropical areas during the winter seasons. So you have radiational fog in the tropical areas which is formed because of the heating and cooling of the continental interior, specifically in the tropical areas. Besides these advectional, frontal, radiational fogs, we also have categories like steam fog, ice fog. Ice fogs mostly formed in the northern high latitudinal areas of in the northern hemisphere and southern hemisphere. Then you have steam fogs which are also formed along the continental margins, mainly because of the advectional and horizontal movement of wind, where the warmer wind from the continental interiors moves toward the cooler water surfaces, leading to the formation of steam fog. So this was all about the distribution of major types of fog which are found around the world. Coming to the effects of fog on environment and human beings, because fog covers the area with white thin clouds, giving it a blurry smoky appearance, definitely limits the visibility, which hinders the sea navigation, land and air transportation systems. So it is definitely a challenge for the mobility of vehicles during the foggy time periods. Dense fog may lead to severe accidents on high-speed highways and hinder mobility. Landing and takeoff of aircrafts is also delayed by dense fog, causing economic losses to airlines and causing inconvenience. Dense fog is also a navigational hazard. Why? Because in sea, as ships and huge tankers carrying oil sometimes may also collide, since the visibility is immensely restricted, resulting into spillage of huge quantities of oil, causing enormous oil slicks on sea, which is environmentally very disastrous. The most dangerous form of fog is freezing fog. Freezing fog is a type of fog where the water droplets are super cooled and freezes onto objects, because of which these types of fog freezes over road surfaces, making them very slippery, hence very prone to accidents. So it is a kind of fog which is very dangerous, mostly found in the temperate regions and very cold areas of the world. The freezing fog may also lead to roadway icing, which is one of the biggest weather killer in the Pacific Northwest, and freezing fog can very quickly glaze a thin layer of black ice over roadways, making them prone to accidents and slippage. The advectional fog is another great hazard to sailors as it is very thick and persistent even in the presence of strong winds, making the navigation of ships difficult in the oceans. When fog mixes with pollutants like sulfur, sulfide fumes and sulfur dioxide, especially near urban areas, they lead to the formation of special type of fog which is called as smog, which is very toxic, poisonous and hazardous to human health also. So a very blur, smoky kind of appearance can be seen over cities, especially during the winter season in the tropical areas, and even in the temperate regions you can see a very blackish smoke like appearance, which is where fog mixes with the dust particles and smoke, and this type of smog is very detrimental to human health and it is toxic. However, sometimes the fog are also economically beneficial. For example, they protect the tea and coffee plantations from scorching sunlight, just like the mocha coffee of Yemen, and these regions highly benefit from it because the coffee plantations are not scorched, and these foggy conditions protect these coffee plantations from scorching sunlight. But besides this, the impact of fog is mostly challenging for human beings since they restrict the mobility because of the hindered visibility. Coming to the summary of the video, fog is basically a collection of liquid water droplets or ice crystals suspended in air. So these are special types of clouds which have water droplets mostly, and they remain suspended near the ground surface because they are very light, and they form these white, blurry, smoky appearances hindering the visibility. It can be formed over land and ocean surfaces both. So you have different types of fog which are found in different regions. For example, you have radiational fogs which are mostly found over the ground surfaces. Then you have advectional fogs which can be formed over oceans as well as the land surfaces. So they can be formed over stable conditions also, as well as they can be the outcome of movement of air also. So based on different conditions and different area of origin, different phenomena because of which fog originate, they are generally divided into most common types which are called as radiational fogs, formed mainly because of heating and cooling of the Earth's surface. Advectional fog, which is the outcome of the horizontal movement of air. Upslope fog, which is a subcategory of advectional fog only when the air rises the mountain peak and leads to the formation of fog. Steam fog is another category of advectional fog where the fog is formed over the ocean surfaces. Then you have frontal fogs, which are most common in the frontal areas, mainly formed because of the contrasting properties of two different air masses leading to the formation of fronts, and consequently the fogs are formed in these regions. And finally we have ice fog also, which are found in very chilly, cold, generally minus 29 degrees Celsius temperatures and below, and these are generally found in very cold areas, hence they have ice crystals instead of water droplets. Besides this, you also have freezing fog, as we have discussed, which are formed in very super cooled conditions, and all these types of fog have profound impact on weather, economic activities, transportation, mobility, human health and environment. So in one or the other forms, these fogs impact the overall life and at different atmospheric circulations and patterns on the surface of Earth. And these are the manifestations of different climatic conditions. These are the manifestation of variable atmospheric conditions which are existing on our planet. So I hope this video was informative. Thank you.